Thank you for the great introduction.
Thank you.
So you already introduced a lot about what I do and what I did that I was teaching. I also write a blog occasionally. Now I also write a lot on Storyblok as well. I also have a Twitter where you can send me messages if you want to talk to me. And I will show a CodePen example later. So there's also a lot of stuff on CodePen that I did in the past. But today we want to talk about CSS Houdini. Maybe you can show your hands if you used it before or tried it out. I know Oliver tried it out. He also gave a talk about it. So what is CSS Houdini? CSS Houdini is defined by the Mozilla network as an effort to define low-level CSS DOM APIs. So we can extend CSS with our own kind of features. So that kind of means it's extending CSS via JavaScript. It's similar to how service workers work for our browser's cache. So it helps us add features to the CSS engine. With Houdini, we get access to the actual rendering engine. So especially the CSS object model. And we can hook into the rendering engine and tell the browser how to apply different CSS things during the render process. So we can directly render things by writing JavaScript. And this is pretty great because we don't need JavaScript polyfills anymore, but we can write our own CSS features. We can't use it yet because it's not in all browsers, but a lot of the APIs are already shipped in a majority of the browsers. So if we check, is Houdini ready yet, the website, which is pretty great. We have all the different APIs there are in Houdini, and the Paint API, the Properties and Values API, and the Typed Object Model are already shipped in a lot of the browsers. Mozilla has a lot of the features not implemented, but they're considering implementing them. If you want to test them out, I recommend using Chrome because they have most of the features implemented. And you can do that by going to the Chrome flags URL you see here and activate the experimental web platform features. And then you can play around with all the different Houdini things. So I already mentioned there's a lot of different Houdini APIs we can make use of. And I want to explain a little bit more what the different APIs are and then dive a little bit deeper into the Paint API. The Houdini APIs, like I already said, are closely to the CSS object model, to the CSS parser, the cascade, the layout, the paint, and the rendering stages. I drew a little picture to make that more clear. So we have 3 high-level APIs. These are the APIs that are really close to what you see on the screen. So the Paint API lets you paint different things, which we will see later. The Layout API lets you directly influence the layout and how things are laid out in the rendering process. And the Animation API lets you directly animate things based on user input. These are really fun to work with and to try out, and I will have a little demo for the different APIs later. And then we have the low-level APIs. They're kind of the foundation for the high-level APIs. So we need all the low-level APIs to kind of do what we can do in the high-level APIs. And these are not really seen. So these are in the background. They're more closer to the rendering engine, but they're just as necessary to extend CSS and create new CSS features. I already said the high-level APIs, so we can see on the right the support for the high-level APIs, the Layout API, the Paint API, and the Animation Worklet. The best support is for the Paint API, which is also the example I'm going to show later. The Layout API and the Animation Worklet we can already try out, and a lot of the features are implemented in Chrome, but they're not shipped yet. And yes, they're really close to the rendering process. So the style, layout, paint, composite steps we have whenever we render something on the screen. The Paint API is anything we can paint. So for example, changing the background of something, changing the border of something. And it's using the Paint API is really similar to drawing something with a 2D canvas. And it already has quite good browser support compared to all the other APIs, but we can't use it yet in Firefox. Here's a little demo that kind of shows what the Paint API can do. So we can paint different things. We can use the custom property API to like adapt all this painting. So different colors, different sizes, different opacity, different images. And we pass these variables to the CSS renderer and paint anything we want to paint basically. This example is from CSS Houdini Rocks. You can see on the left. There's a lot of really cool features and demos on this CSS Houdini Rocks site. And then if you want to read more about what it actually can do, you can look at this interactive demo, Houdini Glitch Me/paint, and it also has all the other APIs you can read about. The next one is the layout API. So this is the rendering step where we kind of find out where elements are positioned, what their alignment is. And by using this API, we can basically make our own display properties. So for example, a mentionary layout. And we can also polyfill layout specs like container queries. Here's an example by the Google Chrome Labs, which is basically a mentionary layout built with the layout API. And we can adapt the columns and the paddings with the custom properties. And all the elements are laid out in a mentionary layout, which is pretty nice. We also have the third one, the third high-level API, which is the animation API. And the animation API allows us to do really performant animations tied to user input. So for example, parallax is something that we can do with the animation API, or other animations that are based on user input. Anything that might be reliable on request animation frame gets more performant by using this animation API. There's another example from the Google Chrome Lab. So what they built is a scrolling animation, a Twitter header that animates dependable on the scroll position. So it's also really nice for different scroll positions and to animate objects based on the scroll position. And then we have the low-level APIs. Here, the properties and values API is really a core API that works with all these variables. And the typed object model is also like a core part of doing all these things with the other APIs. And then we also have the font metrics API, which is really early stage and not shipped in any browser yet. So they're just drafting around it. And also the parser API. The typed object model is kind of what exposes CSS values, and instead of just having strings, we can have different objects. So for example, for font size, we can have an object that says, well, the value is 20 and the unit is pixels. And we can also say, well, this value is a number, this value is a string, this value is an EM value, and directly say what type something is in CSS, which is kind of important to be able to work with the different values. And then we have the custom properties and values API. And this API kind of gives structure to the CSS variables. And it allows us to extend the CSS variables by adding a type. In the bottom is a short example of what that might look like. So we could have a variable color primary. We could say if it inherits, what the initial value is. And we need this API to do kind of what you see here in the demo. So we pass variables with different things to the Houdini worklet. And in all the demos, you will see a lot of the custom properties and values API, because it's like an important part of building different demos and features. And then we have the font metrics API, which is very, very early stage. And it kind of lets you know how big text elements and how big text elements are and how they're rendered on the screen. An example for why you would need that would be a multi-line dynamic text truncation. So you can do different things with text, but there's not a lot of demos on that yet. At least I haven't found a lot of them because it's just a draft for now. And the last part that we kind of need to know about are the worklets. So the worklets are what we load in our browser. We have a paint worklet, which is basically the paint API with an animation worklet, and we have the layout worklet. And we can load these different worklets, which we'll see in the example later, and then have this new CSS feature and use it in CSS. And what's important to know about worklets is that they have a really limited access to the global scope. So we cannot have access to, for example, the window object, but we can only pass like certain things like a variable to the worklet. But other than that, it doesn't have a lot of access. All right. And here on the Houdini glitch.me, you can read more also about the worklets and about all the other APIs. But in my talk, I want to focus more on the Paint API and show you like a real example that I built how the Paint API works. So I already kind of mentioned it's very similar to the Canvas drawing context. So we can use JavaScript to create custom drawing functions, and then we can use these functions for any CSS property that expects an image. So for example, the background image or the border image can use this function we create in JavaScript and then paint something similar to a canvas. A cool example for that is Extra CSS, which Yuna created, which does a lot of border effects and background and underline effects, and is a little library that is built with Houdini and that brings really cool painting features to different elements. Why do we need it? In the past, we had a lot of polyfills to kind of make up for the missing support in CSS. One example for that would be the conic gradient polyfill. But the problem with that is that JS polyfills really depend on JS, and they can get problematic in terms of performance. So it's a lot better now if we can do it in Houdini, because the performance is a lot better and closer to the actual rendering engine. We can also reduce the number of DOM nodes. So for example, when we draw lots of particles, that's also like a performance kill if you do that with DOM nodes. And in Houdini, that's not a problem because it's directly rendered and similar to the canvas. And basically with the Paint API, we can create our own CSS painting features. So anything that you would use for a background image, like a linear gradient or anything else. So when we have a worklet, we load it. So in this example, there was a worklet called slanted background that was loaded. We can use it in CSS by using this paint function. So we have a paint function, and then we have the name of the worklet that was loaded. In this example, slanted BG background. Since the support is not in all browsers yet, we always need to test for support. So we should make sure to use this support statement and test if that browser actually supports it. And otherwise have a fallback for this feature. So we have a normal background color, but if it supports the Houdini API, we paint our fancy background. And then we need to register this worklet in JavaScript. So first we need to create a class for our painting. We need to register this painting class and then also load the worklet. So the most minimal example of what that CSS Houdini Paint API class could look like is a class that's called slanted background, and it has this paint function that essentially does the painting for us. And the paint function has different parameters like the context, the geometry that has the width and the height of the element, the props and the arguments that are given to the worklet, like the variables. And then when we have this class, we always need to register it. So we need to call this register paint function, give it a name, and this name is what we use in CSS later with this paint function and the class of Houdini that we just created. And then we also need to make sure that there is the support in JavaScript. So here we can also have a support test with if paint worklet in CSS, then load this module, our JavaScript file that has the class. All right. So now I want to show you a real example and of the Paint API. I created this example in January. It was the first time I played with Houdini. But it kind of has a little bit of history how I got there. 2 years ago, I went to FFconf and I saw a really great talk by Tim Holman. And he basically showed his generative artistry.com website, which shows a lot of different generative art in Canvas. So he has really detailed tutorials how to create different drawing functions, and it's really, really nice, and I was super impressed with that. And then about half a year later, I went to CSSConf, and I saw this talk called Design System Magic with CSS Houdini by Samuel Richard, who works at Google and does a lot of CSS Houdini, and he also did this interactive demo site that explains all the different worklets. And when I saw this talk, I remembered the other Canvas talk, and I thought, well, Canvas and Houdini, they seem really similar. So basically, most of the things that we can do in Canvas, we can also do in Houdini now. So I took one of the tutorials from this generative artistry website and looked at the code and kind of tried to port that into Houdini. And they're basically the same. So in Canvas, we have a width and height of the canvas. In Houdini, we have this geometry argument where we can read the width and the height of the element. So we can use all that to basically create the same effect for example, a button background or a card background. So I took different examples from the generative artistry website and ported them and played around and gave them different input parameters with the custom properties API. And that's kind of what came out of that. So we have the different art patterns, and then we can adapt them. We can make them bigger, smaller with the input properties. We can have different drawing functions. So we can draw lines, we can draw triangles, we can draw the tri-division pattern. And it's really, really performant compared to if you would do that in other things. So I want to walk you a little bit through what you need in order to do something like this. The first thing, since it's still experimental, is to test for the support. So we have to make sure that it's supported, and otherwise give some kind of warning. In my example, it has a little warning in the top that says, well, your browser doesn't support the CSS Paint API. And if it supports it, I'm loading only the JavaScript file of this code pen. So, which only has the class and the register paint for the worklet. So we add this module, we add the Paint API worklet. And then we can already use it in CSS. So here on this card element that I have here, I call the paint function with the generative class, which is what I called it when I registered it in the previous step. And then I have different variables that I pass to it. So I have a type, we can draw lines, we can draw triangles. And this type is determined by radio buttons that just change depending on which button you click. Then I have a size, so bigger or smaller, depending if I want to draw lots of triangles or only a few triangles. We can change the color, and we can also change the width of the lines. And if you open the CodePen, you can play around with these and see the effect of what happens. And then the actual Paint API stuff happens in this JavaScript part of CodePen. So first, I said we need to check if it's supported. If it's supported, we can register the paint. We give it the name, generative. That's what the name we use later in the CSS. And then we have a class that has a paint function. In this paint function, we take the different properties we just set in CSS. So what type it is it triangles or lines? How big should the triangles be? What line color and what line width do we have? And we can read all these different properties once we have the static get input properties. So we tell the worklet to get these properties from the element. And then we can read and say, well, this is a string or this is a number, and set, for example, on the context, the line width or the stroke style. This is also really similar to what we already know from Canvas. And then I have a toggle of the different functions. So depending on which button I click, I call a different functions with my context, with the width and the height of the element, and the size of the triangles, basically, or the lines or the Joy Division waves. And then I call my drawing function. In the drawing function, we have all the code that basically is the same as the tutorials of the generative art website. So we have a context we paint on. On the context, we move to X and Y coordination, and we draw a line or an arc or whatever we need to draw on the canvas. And then we create a stroke because we're not doing shapes, we're only doing strokes. And that's basically all I need for that feature. So that's basically all I need to draw these different backgrounds. And yeah, that's all we need. What's cool about it is that you can basically build features that weren't there before. So today we have a lot of different drawing things in CSS, like linear gradients or background images. We have this single div paintings that are just done with CSS. But with CSS Houdini, we can basically paint anything that's possible in a canvas and control it via CSS variables. And that's quite powerful because we can easily adapt modules, even if we don't know how exactly it is drawn. After doing this, I kind of thought, well, how does that perform to current CSS features? So how does that perform to using just like a background image with linear gradients or circles? And I tested 2 examples, and you can read the details in the article if you're really interested, and so, to see if one or the other is faster. And basically the painting for both examples is quite similar, which makes sense because it's using the same CSS rendering engine. So the painting performance is kind of the same, so it doesn't make a difference. What does make a difference is that the CSS Houdini module needs to be loaded. So it's an additional thing we need to load. So the time to interactive moves back a little bit by this loading. And that's why we should make sure we have a fallback. So if the module isn't loaded yet, we should give it some other background that's similar to what our module will paint there. It also kind of depends what you do in your painting function. So if you do really complex paintings, it might be a little bit slower than other things. So you should make sure to not do really performance draining things in the paint functions or infinite loops. And what it's really great for is really progressively enhancing and making things nicer. So start with something simple and then making it better and better with the CSS Houdini features. Yeah, so that was a lot and a little bit fast. But I want to kind of give a conclusion on all the different things you heard now. CSS Houdini and all the different APIs, they allow us to hook into the rendering process. So we can directly paint or lay out or animate things directly with the CSS engine. And we can basically invent our own CSS features that can potentially, if they're really nice, add it to the CSS specification. Like, for example, CSS grid is a really big thing that's in the CSS specification, but now developers can create kind of their own features, and that might be something that potentially someone would use in the future. Why would you use it? Well, CSS Houdini and directly doing painting with the CSS rendering engine is a lot more performant than using JavaScript polyfills. We have close access to the CSS object model and the parser, and it's really great for features that really depend on the request animation frame or scroll interactions, like the parallax effects, or like animating elements on scroll or mouse input. And basically, well, you can build any CSS feature like painting or layout that you would want. Not all features are wide supported yet, so you should check is Houdini ready yet and give a fallback if the browser doesn't support it. It's also really good for reducing DOM nodes. So if you need lots of particles or like click effects that do like fancy things, Houdini is really, really great for doing that. It's also important to keep in mind that it's still experimental, so it's not really production ready because mostly Firefox is still missing, and it really depends on what APIs you're using. So the Paint API and the Custom Properties API has a lot of support already, but Firefox hasn't done hasn't shipped any of the APIs. You also need to be careful with animated effects and give like fallbacks when someone doesn't want something to be animated. So don't over animate, and check if someone has these reduced motion queries activated. And it's really, really great for progressive enhancement. So to do things on top of already existing features and to create something that wasn't possible before with CSS. In the end, I want to give you some pointers on how you can get started with the CSS Houdini API. I already mentioned the Houdini glitch meme, which was made by Samuel Richards that I mentioned before, and has really a lot of really good examples on all the different APIs there are and really explain them in details. There's also a GitHub that's called Awesome CSS Houdini that has podcasts, videos, articles, and examples you can look at and try out. That's also where I found a lot of the examples I was interested in. We also saw a few of the demos of CSS Houdini Rock. So here you have like really useful examples you might use in your project. And they also have this interactive adaptation via the variables where you can really try out what you can change. The Chrome Labs is also a good starting point. So they have a collection of different examples for all the different APIs to show kind of what they're made for and how you can use them. And then there's a lot of good articles on the Paint API. So CSS Tricks and LogRocket have two really nice articles on the Paint API. You can find a lot of articles on the Google developers. And there's also a really good Smashing Magazine article that just gives an overview and explains CSS Houdini. And you can also find these slides that I just showed on my Noticed, where you can go over all the links and look at all that stuff later on. All right, that was already all the things I had to tell you. You can also check out my blog. You can write me a message on Twitter. I have a lot of other animated examples also in CodePen. And I also linked the Storyblok website. And if you're interested in Storyblok, it's a headless CMS that kind of lets you use your own technology like Next or Next or whatever static site generators you use and have a visual editor with that. So you can also ask me anything if you're interested in Storyblok itself.